Hi, my name is Caroline Wood. I'm a student at SenGen who's from the University of Toronto. Here at SenGen, I'm currently looking into different open source projects and how that can help SenGen and its SMEs, its student projects, and members and partners. So what I'll be talking about today, I'll first give you an introduction about what this presentation is going to be about. Then I'll give a brief overview of the Linux Foundation in the context of NFV. I'll then be talking about the interconnectivity of some Linux Foundation open source groups. Then I'll give you an overview of the OPNFV, and then finally I'll be going into the open source groups, OpenStack, a bit of Kubernetes, OpenDaylight, FastDataStacks with a bit of FIDO and DPDK, ONAP, and then finally Panda. So the questions that are going to be answered by this presentation is, how are the following Linux Foundation projects related? We've got OPNFV, OpenStack, which isn't a Linux Foundation group, but it's relevant, OpenDaylight, ONAP, FastDataStacks, and Panda. And then I'll be talking about which groups consume what and which groups provide what to one another. The scope of this presentation is more of what these connections are and why they exist, as opposed to how these groups are integrated on a technical or low level. So start off by giving an overview of the Linux Foundation. Every group that I'm going to be talking about, except for OpenStack, is a Linux Foundation group. And the Linux Foundation group considers open source software as the currency to enable the greatest shared technology investment in history. And basically, what the Linux Foundation is doing is trying to bring together all of these open source groups and harmonize them so that we can have standardization and interoperability with open source software for NFV and SDN. So a first glance at the connections between these projects I'm going to be talking about. It looks very complicated right now, but I'm going to be explaining every connection. Basically, for now, just know that the projects in the blue box are all Linux Foundation groups. OpenStack is a community of its own, but it's very relevant because all of the other groups are leveraging it in some way. And then FastDataStacks itself is an OPNFV project. So for the rest of the presentation, this is going to be the format. I just want to make it very clear because the connections can get a bit confusing. So first I'll be going over OPNFV, and I treat that as the central project because it integrates and brings together all of the other projects that I'm going to be talking about. So I'll just go into what is it. And then for OpenStack, as I said, all of the projects in this research are leveraging it in some way, so I treat it as the backbone of the research. And I'll be talking about OpenStack in OPNFV solely. Then for OpenDaylight, FastDataStacks, ONAP, and Panda, I'm going to be talking about their role in OPNFV, and then as well their connections to one another. For ONAP and Panda, I'm also going to give an overview of what they are because they are fairly new or lesser known open source groups. So we'll start off with OPNFV. There's also going to be a little table of contents at the lower right in case you lose track of where we are. So what is OPNFV? It is a Linux Foundation open source project that is creating a standard framework for NFV through building NFVI, Vim, and now Mano as of the D release. And they are also subjecting all of the upstream projects that they integrate into this reference platform through their continuous integration, continuous deployment processes. So their operations can be categorized into three things. There's integration, testing, and enhancements, all of which I'm going to go over now. So to start off with integration, on the left there's a diagram of all of the open source projects that are integrated in OPNFV as of OPNFV Danube. And all of the ones that I'm going to be talking about are outlined in red. Panda can also be in this diagram for Euphrates, but it hasn't yet been integrated, and I'll be talking about that later on. So on the right, we also have the ETSI NFV architectural specifications, and in that way you can see that OPNFV is trying to adhere to these specifications, although currently VNFs are out of scope for OPNFV. So now on to testing. The main goal with OPNFV testing is to ensure automated and continuous testing. They do their testing through use of scenarios, which combine different components and platforms with specific configurations to test the interoperability of those components. And there's 55 scenarios in Danube. One of them, as an example of a FastDataStacks scenario, is OpenStack, OpenDaylight Layer 3, FIDO with high availability. And then through the OPNFV RelEng and Octopus project, they create the CI/CD pipeline that deploys and tests scenarios on Pharos lab infrastructure. So now OPNFV projects. This is where we see the enhancements and new features coming up. All of the upstream projects that OPNFV integrates, they're also providing enhancements to these groups so that they can meet certain use cases, comply with certain scenarios. So these are only a few OPNFV projects, the ones that I find relevant to this presentation, but there are so many more. So now on to OpenStack. OpenStack is used as Vim, an SDN controller, and Mano in OPNFV. And as I mentioned, I'm treating it as the backbone of this research because all of the groups that I'm talking about are leveraging OpenStack in some form. So to start off with OpenStack-Tacker, that's an OpenStack project that was initially building a VNFM, although they have expanded now to include an NFV orchestrator. It can still be used as a VNFM though, so that is how it would work alongside OpenO, which is a part of ONAP, and I'll be talking about that later. So OpenStack-Tacker is used for Mano in OPNFV, and the platform itself is based on an ETSI NFV architectural framework, so it would be acting as the NFVO and the VNFM in that architecture. Next up is OpenStack Neutron, which acts as an SDN controller in OPNFV. It can be used as an API translation layer and an SDN controller, meaning that if you're going to use OpenStack Neutron as the SDN controller, the functionality would basically be merged with the Vim functionality. Otherwise, you can just use Neutron as an API translation layer if you're going to be using a third-party controller like OpenDaylight or OpenContrail. Usually you wouldn't see OpenStack Neutron being used as an SDN controller in more complex environments. So again, to reference the ETSI NFV architecture, there's a lot of different ways SDN controllers can be used, although we'd be looking at case number 1 here where OpenStack is used as the Vim and SDN controller, and the functionality of those two are virtually indistinguishable. So now OpenStack as the Vim, it is the primary Vim for OPNFV, but I also want to mention that Kubernetes is being experimentally supported in Danube as an alternative. There's one functional Kubernetes scenario in Danube, and that is Kubernetes on bare metal deployed with the Droid installer. And then there's also another experimental scenario, which is Kubernetes on OpenStack, and hopefully that will be enabled by the Euphrates release. OPNFV also has a new installer project called Armada, which leverages OpenStack Helm to create the installer framework, and it creates the installer framework for OpenStack Helm, rather, to bring Kubernetes and OpenStack together within OPNFV. So again, with ETSI NFV, OpenStack is acting as the Vim in the lower corner. So now here's the same diagram that we saw on one of the first slides, and it just shows OpenStack now. I have a black line there because you can see that it's integrated into OPNFV's platform. So now for OpenDaylight as the SDN controller. OpenDaylight works as a full-blown modular SDN controller. It works with OpenStack and other orchestration layers northbound, and works southbound with a variety of virtual switches. For the same diagram that we saw earlier with the implementation of an SDN controller, in this case we'd be seeing case number 3, where the SDN controller is built into the NFVI. It's also possible to see an SDN controller in case number 2, where it's deployed as a VNF, but since VNFs are out of scope for OPNFV right now, there aren't any scenarios that involve OpenDaylight in that configuration. So now for OpenDaylight's integration with other groups, OpenDaylight is very well integrated with OpenStack, and what this integration is doing is basically taking the layer 2, layer 3 responsibilities away from OpenStack Neutron and delegating them to ODL. And ODL handles the flows for the OpenStack compute nodes, basically. On the other hand, we've got FIDO. OpenDaylight is integrated with FIDO through the work of FastDataStacks, so I'm going to talk more about this integration a little later on. But for now, just know that FIDO is a virtual switching, virtual routing component that can be plugged into the OpenDaylight SDN controller. So now I want to outline a scenario in particular that brings together OpenDaylight and FIDO, and this is called Nirvana Stack. It was proposed by AT&T last year in 2016, and it's an OPNFV scenario that brings together OpenStack-ODL and FIDO. So basically what Nirvana is a combination of OpenDaylight's GBP, group-based policy, and OpenDaylight's NetVirt. So NetVirt and GBP are both OpenStack providers for ODL, and they both provide network control solutions for ODL. So since the two were so similar, OpenDaylight has decided to merge them into an ODL converged, they call it. And now with this ODL converged, they still have the ability to interface with multiple northbound systems like OpenStack or Kubernetes, and the combination now of all of the southbound virtual switches, including FIDO. So the Nirvana stack itself uses OpenStack Newton. It uses the ODL converged that we talked about. It uses FIDO with the VPP and DPDK. And then it's using the Apex installer from OPNFV and the system test, func test, and yardstick. So now for OpenDaylight's relationship in the chart we saw earlier. It's integrated with both OPNFV and OpenStack as we saw, so there's the black lines there to indicate that. So FastDataStacks for data plane acceleration now. FastDataStacks itself is an OPNFV project, so it's not exactly Linux Foundation project, but it's under that umbrella. And FastDataStacks basically brings together, it involves the virtual packet processor, or the VPP technology from FIDO. It brings that into OPNFV's existing test scenarios. So FastDataStacks is leveraging FIDO now, which is another Linux Foundation project. And FIDO is the one that's integrated in OPNFV. FIDO, as I mentioned, leverages VPP and DPDK for virtual forwarding data plane acceleration. And FastDataStacks basically brings together FIDO, OpenDaylight, and OpenStack within its scenarios. So just to give you an idea of where FIDO acts, it would act in the virtual network component of the NFVI. So now FastDataStacks makes all the necessary enhancements to the platforms and components involved in these scenarios. So it's making enhancements to OpenDaylight to make things work, it's making enhancements to the Apex installer, so on and so forth. So this diagram just shows a typical FastDataStacks scenario. Usually you'll have OpenStack as the VM manager, OpenDaylight as an SDN controller, and FIDO for virtual switching. In more simple deployments, you can also have scenarios with no SDN controller where you just integrate directly OpenStack with the VPP. And then OPNFV is donating their Apex system installer and their system test, func test, and yardstick. So now FastDataStacks relationship to this chart is that basically FastDataStacks is an OPNFV project, which is leveraging FIDO and the VPP technology in order to integrate FIDO with OpenDaylight and OpenStack. And then FIDO is directly integrated into the OPNFV reference platform. So now for ONAP. So what is ONAP? I'm just going to give a brief overview. It's a merger between the Linux Foundation's OpenO and AT&T's eComp, and this merger was set in place of February of 2017, earlier this year. Basically, with these two Mano platforms combining together, we're able to take advantage of the best features of each group and have a stronger overall Mano platform. The challenge now is that there's millions of lines of code from each group that developers are having to merge. In terms of the actual merge itself, ONAP is more so derived from eComp architecturally in the fact that it still has a design time environment in addition to its execution environment. And to give you a better idea of how these groups are merging, I just have this chart here that explains the modules that have been taken from the open source eComp and from OpenO to combine the overall ONAP platform. So ONAP and OPNFV is going to be used for Mano. And it's actually OpenO that's integrated into Noob right now, which is an important distinction because OpenO and ONAP are very different. There's going to be a lot of work ahead to integrate ONAP into Euphrates. And this integration of ONAP into OPNFV Euphrates is being done by the OPNFV Opera project. They're planning on picking up where they left off with the OpenO integration and going from there with ONAP. And to give you an idea of the SCNFV, ONAP acts as the NFVO and VNFM, and they're working on having it interface with OpenStack as the VIM. So now for ONAP OpenStack integration. The Opera project that I just mentioned wants to define the OpenStack, no SDN, ONAP, no HA scenario. So there's a lot of work being done in integrating ONAP and OpenStack right now. ONAP rather is built on OpenStack, so they're using some of their core services. Most notably, they're using heat templates. So this is the ONAP architecture on the right-hand side here. I just want to highlight what's in the red circle. You'll see in there there's the MSO, which is the Master Service Orchestrator. It's just a top-level orchestrator. The MSO is using heat templates to tell deployment and configuration automation how to build the end-to-end service. And it's filling up these templates by interfacing with the controllers below and getting network information through them. And now speaking of those controllers, they're actually based on an OpenDaylight framework. So ONAP leverages OpenDaylight for its controller framework and makes its own additions on top of that. So now ONAP's relationship to the graph. This is sort of a forward-thinking graph that I have here with ONAP because these integrations haven't been completed yet, but they are planned. So the integration line with OPNFV, that will hopefully be done for the Euphrates release. And the integration line with ONAP as well, that should hopefully be done in the near future. And then other than that, ONAP is leveraging OpenStack for its heat templates, and ONAP is leveraging OpenDaylight for its controller framework. So now for Panda, which is used for network data analytics in OPNFV. So what is Panda? It's an open source big data analytics platform that brings together many open source technologies. Its goal is to remove the complexity of combining multiple technologies into an end-to-end solution for data analytics so that you don't have to do it yourself. These are the capabilities of Panda. I'm not going to go through them, I'll just leave them on the screen. But basically the long-term goal for Panda is that they want people who don't have a background in big data technologies to still be able to use the platform easily. So where does network data analytics fit into ETSI NFV? Basically, with the specifications there are now, more extensive capabilities are needed for monitoring and analysis. And this is because the existing OSS architectures can't process the data as fast as it's coming in. So Panda, as a big data analytics platform, can be used to improve these operational analysis functions. And how it's going to do this is by working with the orchestration and control state. The orchestration and control state is loosely related as a couple system to the OSS architecture, and that's because the analytics that are coming into Panda need context. They need context from the control state. So the control state is providing this context to the data so that Panda can then analyze it and provide feedback on how to optimize the deployed services and other things like that. However, this doesn't erase the need for all monitoring and analysis in the orchestration stack. So for example, ONAP, you'd still need it to do things like the VNFM would need to manage its VNF in case of failures and autonomously address those failures. But basically what Panda could enable is that you're allowing yourself to monitor the state of your system and then trigger changes as needed to self-heal VNFs to optimize their how they're running. So now Panda and OPNFV. This integration is planned for the Euphrates release through the Bamboo project. And the Bamboo project is another OPNFV project that's leveraging Panda to create an analytics subsystem within OPNFV. With the subsystem, they want to post-process the test results from FunkTest, Yardstick, any other test platforms on OPNFV, and then store these results in a database. And then they also want to integrate Panda with some FastDataStacks scenarios, the ones that I have on the screen right there. That is the second goal of the Bamboo project. So to give you an idea of where Panda is going to be incorporated into OPNFV, there's two deployment cases. One is where we're using it to post-process OPNFV test results and store them in their existing database. And the second would be to enhance the FastDataStacks scenarios that we saw on the previous slide. And then on the right here, it's just the high-level architecture of the analytics subsystem. You can see that the test results would come in through OPNFV. You'd have the data plugins in Panda being able to receive that data, get it analyzed, processed, and then pushed out to the end user in a human-readable format. So Panda leveraging OpenStack. Panda is designed to be deployed on OpenStack, and it's also using Heap for deployment and Swift for object storage. So it's using OpenStack quite a bit. On the right here, I just have a diagram to show you how OpenStack would be used in creating a Panda cluster, for example. You can see that it's being used for deployment of the platform, and then Heap is being used for the creation of the cluster. So now Panda integrating OpenDaylight. Panda is pre-configured to ingest data from OpenDaylight, and they call OpenDaylight a producer for Panda and for Apache Kafka, which is the front door of Panda. So OpenDaylight brings data into Apache Kafka, which then comes into Panda. So they recommend you use OpenDaylight for netconf notifications or SNMP metrics and traps. And this integration is done through the prod ODL Kafka plugin. So now Panda's relationship to all of this, we have the final diagram up now. Hopefully it makes more sense. But for Panda, again, this is a forward-looking diagram. So we've got this integration with OPNFV that's planned for you for ETSI, and the integration with OpenDaylight, Fido, and OpenStack that's hopefully going to be done through the Bamboo project. And then we've got PNDA Leveraging OpenDaylight for data aggregation, and PNDA Leveraging OpenStack for heat templates for deployment and for Swift object storage. So now to bring everything together, I want to mention an OPNFV initiative called Cross-Community CI, or XCI, and the main goal of this is to facilitate faster integration of the groups that you see on the right-hand side over here. It's going to do this by working with the master branches of Upstream projects so that developers always have access to the latest versions of these projects. Some of the benefits of this is that it's going to cut the time it takes to develop new features. You'll be able to identify bugs faster, get daily feedback, and fix issues faster. You can run additional testing on OPNFV infrastructure and then provide feedback to the OpenStack community or any other community on what they need to work on. And it also will make the solutions put in place available to the other Linux Foundation networking projects that OPNFV is working with. So to give you a rough idea of how this would work, is that the projects proposed by OpenStack developers for the projects that XCI is using will be verified and tested by OpenStack CI, reviewed and then submitted to master by project core reviewers. So now the key takeaways of this presentation. This is not at all a comprehensive overview of all open source projects. There are so many more, but I've just chosen some of the ones that are most relevant to OPNFV right now. The Linux Foundation envisions a unified open architecture for networking and orchestration projects. So through the Linux Foundation's OPNFV project, they're bringing together all of the groups that I've talked about. And then every open source project leverages the other projects in some way, so that picture that I showed you, that diagram with all the arrows, you can see that there's a complete mess of connections in the ways that the groups are leveraging one another and finding success through working with one another. And then finally, OPNFV integrates these projects and subjects them to their processes and incremental quality releases. So thank you for listening. I hope you found this presentation very helpful. I've got some references on the last slide here, and thank you for watching.